This is problem number 4 from section 7.4. It says use the given information to find sine s plus t, tan s plus t, and the quadrant of s plus t. They give you cosine s as 15 over 17. They give you cosine t as 3 over 5. And they say s and t are in quadrant 1. All right, so this problem is very similar to problem number 3 that we just did. They tell us s and t are in quadrant 1. So let's go ahead and draw those quadrants here. So quadrant 1, 2, 3, 4. They say they're in quadrant 1. Well, we know that cosine is positive quadrant 1, and so is sine. Right? We got positive, positive. We've got negative, positive on this one, negative, negative, and positive, negative down there. So on the top, quadrant 1, we know that both cosine and sine are positive. Now they're going to ask us for s plus t, sine s plus t, and tan s plus t. So we're going to actually need to know, because of the sum and difference formulas, we're going to need to know not just cosine s, we're going to need to know sine s, and we're going to need to know sine t instead of just cosine t. So what I need to do is I need to write a triangle for cosine s. And remember, s and t are different angles. So these are completely different fractions for two different triangles. So I need to say that this is triangle S. Triangle with angle S, we'll say that. And this is triangle with angle T. Okay, so we know we're in quadrant 1, so we'll draw that real quick. There's our triangle. We know that if it's cosine S is 15 over 17, that really means that this is 15, this is 17. So we need to go through and find this side here. So in order to find this side, we're going to use the Pythagorean theorem. We're going to say 17 squared equals 15 squared plus b squared. 17 squared is 289 equals 15 squared, 225 plus b squared. I subtract this over, so 289 minus 225 is 64. Square root each side, I get 8. So this side is 8, meaning that I have, I've got cosine of s, which is 15 over 17. I've got sine s, which is 8 over 17. Right, opposite over hypotenuse. The only one I don't have is tangent yet. We'll wait to get tangent here for a little bit. Let's look at the second triangle, triangle T. So for triangle T, we've got this triangle here, and this would be cosine T is 3 over 5, so it's 3 and 5. Now you can see this is a 3, 4, 5 triangle, but just for the sake of working this out, let's go ahead and say that 5 squared equals 3 squared plus b squared. So that's 25 equals 9 plus b squared. That's 16 when you subtract it across equals b squared. So we have 4 equal to b. As you can see, 3, 4, 5 triangle. And that means cosine of t we knew already was 3 over 5, but now sine of t is 4 over 5. Okay. So for part A, they want us to find sine s plus t. And we know sine of s plus t, if we come to our sum and difference formula, we use the addition for sine. That'd be sine s times sine t, or no, times cosine t, plus cosine s times sine t. Well, we know that that is equal to sine s, which is 8 over 17, times cosine t, which is 3 over 5, plus cosine s, which is 15 over 17, times sine t, which is 4 over 5. When we multiply those out, we get 24 over 17 times 5 is 85, plus 15 times 4 is 60 over 85. And so we end up with 84 over 85. So 84 over 85 is our answer for sine of s plus t. Now we want to find tangent of s plus t. So when we want to find tangent of s plus t, we need to go through and use the sum and difference formula for tangent. So it says tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. So let's go ahead and use tan alpha, and we can say that this is tan s plus tan t over, so tan s plus tan t over 1 minus tan s tan t. Okay, so we got the formula written. The problem is we do not know tan s and we don't know tan t. But down here we've got cosine s and cosine t, and we can find tan because we know tan is sine divided by cosine. So let's go ahead and write those out real quick. So we're going to say tan s equals sine s over cosine s, which is equal to 8 over 17 over 15 over 17, which is equal to 8 over 17 times 17 over 15 when you flip it, and that's 8 over 15. Okay, so now we know tan s is 8 over 15. What about tan t? Well, tan t is sine t over cosine t. I know that sine t is 4 over 5 over 3 over 5. When I flip and multiply those, I get 4 over 5 times 5 over 3, which is 4/3. So I now know tan s and tan t. So now we can go through and we can actually use this formula. So we're going to say equals, so tan s is 8 over 15 plus tan t, which is 4 over 3, over, so tan s plus tan t over 1 minus tan s, which we know is 8 over 15, and tan t, which is 4 over 3. So we can go through, find a common denominator here. We can just multiply this one by 5 over 5. So we get 8 over 15 plus 20 over 15. Over, on the bottom, we're going to end up with a denominator of 45 here. So I'm going to kind of do two steps at once and say that this is 45 over 45, which is 1, right? Minus, this will give you 32 over 45. Just saves us a step. 8 over 15 plus 20 over 15 is 28 over 15 over 45 minus 32 gives you 13 over 45. We flip and multiply there. So 28 over 15 times 45 over 13. The 15 and the 45 can reduce. And when I reduce those, I end up with 15 crossing out. This leaving you just with 3. So 3 times 28, that's 60, 84 over 13. So tan of s plus t is 84 over 13. So that's part A. This is part B. Lastly, what's part C? So part C, they say the quadrant s plus t. What quadrant is s plus t? Well, we know tangent is positive because we just found tangent being positive. Tangent being positive means we're either in quadrants 1 or 3 if tangent's positive. Well, we know that the sine was positive as well, and sine is only positive in 1 and 2. Well, they share a common one, which is quadrant 1, so we are in quadrant 1 still for s plus t.